Okay, number 1 says, what is the domain for the graph below? So right here we know that we're looking for domain, so I'm going to write x so that I know I'm looking for the x values. When I go down to my graph, these are my y values, these are my x values. So when I am going to write the domain, I'm only going to be looking at the numbers here. This first point, if I drag it back down to the x-axis, I can see that it is at 3. This one is at 5. This next one, 10. This one is at 12. And the last one is at 15. Okay, I'm going to put my squiggly bracket around it, say that that's the set for the domain. Number 2, what is the range for the line segment below? Well, range tells me that I'm looking for the y values. Okay, the y values would be the up and down, right? The y-axis. So we're seeing how far down does it go, and how high does it go. So what's the minimum value, and what's the maximum value for this, for the range, for the y values? It drops back down to -6 here. Up here, we're at +3, so I write that down. So the minimum value is -6, the maximum value is +3. If I want to write this down, I'm going to use a compound inequality. I have a starting point and a stopping point, so starting and stopping. So the minimum value was -6, the maximum value was 3. The values of y are going to be any number between -6 and 3. It does include the value of -6, so we will write less than or equal to, and it does include the value of 3, so less than or equal to again. The value of y is going to be between -6 and 3, so no matter what point I pick on this line, the height of it is going to be between here and here. It could be -6, and it could be +3, or anything in between. Okay, problem number 3, what is the range of the ray? Range is going to be our y values. So we'll be looking at the values on the y-axis, how low and how high. So what's the minimum and maximum on the y-axis? If I look here, I have a point, and I have a line going this way. This arrow tells me that this line will continue forever. So if I follow along this line, will I ever stop going down if we're going forever? The answer is no on that. So I have no minimum value to write down here. Up here, I will have a maximum value to write because the highest point is 1. There's no arrow pointing up further. So this is our stopping point, or our starting point, depending on how you look at it. So if I want to write this, this one's going to stop at 1. So the maximum y value is going to be 1. We're using the variable y because we're talking about the range of the y-axis values, and the number we're going to use is the number 1. That's the only number I have to use. Okay. If I'm on this line and I'm going this way, that means the values of y are decreasing as I move this way. So that means the values are getting less. So y, the values of y will be less than 1 from here down. And it's also going to be equal to 1 because right here it has a closed circle, and that's telling me that does include that value. So it's also equal to -1. Number 4. Johnny jumped off a diving board into a pool. The diving board was 4 feet above the water, and he jumped 5 feet away from the board. What is the domain of Johnny's jump? Well, there's a whole word problem here, but what we're looking at is it says, what is the domain of Johnny's jump? So all I need right here are the x values of the jump. So I'm going to only use the values of x since we're looking for domain. And I have to see if I traced these points back to my x-axis, what is the minimum value and what is the maximum value. So right here, the minimum value would be 0. So minimum x is 0. And the maximum value is 5. If I wanted to write this as an inequality, I have two numbers, so I will write a compound inequality, so I will have two inequality symbols. The lowest number, or the minimum number, is 0, the maximum is 5. We are talking about domain, so we use the letter x. 0 is less than 5, so we're going to use the less than symbol on both of them for the inequalities. And then we have to decide, does it include the value of 0 and does it include the value of 5? Well, I don't have any open circles, so it would include both of the values. So I will put an equal sign with each. So the value of x, or his domain, is saying it's between the values of 0 and 5. He did start at 0 and he ended at 5, so it could be any number in between, any decimal, any fraction. Could include the value 0 and it could include the value of 5. Okay, number 5. If f of x equals 3x plus 5, then f of negative 2 equals what? In this problem, we see that f of x and over here f of negative 2, these are the same thing. All they're doing is they're taking this x and we're going to substitute negative 2 in its place. So it's saying that negative 2 is x in this problem. All I'm going to do is take this negative 2 and substitute it in here and find out what this equals. So I'm going to rewrite the problem as f of negative 2 equals 3 times negative 2 plus 5. This f of negative 2 just tells me that that's what I'm substituting for x. There's nothing to do on this side. This is just a name. So I can act like that's not even there. I'm just going to evaluate this side. I'm going to see what the value is over here. So 3 times negative 2 gives me negative 6. And then we still have the plus 5. Negative 6 plus 5 is negative 1. So f of negative 2 equals negative 1. And really all this is saying is that when x is negative 2, the answer is going to be negative 1. The y value is negative 1. I could write that as an ordered pair, negative 2 comma negative 1. The x value is negative 2, the y value is negative 1. All right, so really this is all just telling you what the x value is. Okay, number 6. If f of x equals x squared minus 2x and the domain is negative 3, 3, and 7, then the range is what? Right here it's telling me the domain is that. So I'm just going to draw a little table real quick. X's and Y's. And I'm going to label the x values. So we have negative 3, 3, and 7. So I need to find the range, or the y values. All I'm going to do is substitute negative 3 in for the x's. So for the first one we have x squared minus 2x. We're going to use that for all three of them. So we have negative 3 in parentheses squared minus 2 times negative 3. Negative 3 squared is 9. Negative 2 times negative 3 is going to be positive 6. So plus 6. And 9 plus 6 is 15. I'm going to write 15 down for my y value here. Then I'm going to substitute 3 in for x. So x squared minus 2x. We're going to substitute 3 in for x, so 3 squared minus 2 times 3. Follow the order of operations. 3 squared is 9. And then negative 2 times a positive 3 gives us negative 6. 9 minus 6 is 3. So my y value will be 3. And then I will use x squared minus 2x again for the last value. This time we're going to substitute 7 in for x. So 7 squared minus 2 times x, or 2 times 7, 49 minus 14 is going to give us 35. So then the range would be 3, 15, and 35. Number 7, if f of x equals 4x minus 3 and f of x equals negative 15, then x equals what? In this problem, they're not giving us the value of x. They're asking us to find the value of x. So if I don't have the value of x, what do I have the value of? And that would be y. We talked about earlier that f of x is the same thing as y, so I can say that y equals negative 15. So if I draw a t-chart, or a table of x's and y's, and I just said they gave us the value of y, so we have the negative 15 here. And I need to find the value of x. When I look at this function notation, this equation here, I know that it's saying this whole piece, f of x, that is negative 15. So if this whole piece is negative 15, then I can take this whole piece and I can put negative 15 in its place. So I'm going to rewrite this equation as negative 15 equals 4x minus 3. Now, I just have one variable. It's the x, and that's what they tell us to solve for. So when I want to solve this, I need to separate my sides, and I need to isolate the variable, or get it by itself. So I'm going to add 3 to both sides, and that's going to give me negative 12 equals 4x, and this canceled. Right? Negative 3 plus 3 is 0, so that's all I'm left with is the 4x. And then I'm going to divide by 4, and we're going to get negative 3 equals 1x. So the value of x in this problem is negative 3. Number 8 says, which statements below are true? We go ahead and look at the graph. The graph's talking about ticket prices for Six Flags. The y-axis is cost. Age is the x-axis. We can see that the age increases from 0 to 90 years old. The cost is between $0 and $10. What this is showing me is that for the ages here, for the ages here, it's going to cost $8. So from here to here, it's showing the ages of 0 to 20 years old. They're charged a price, and on and on. Okay. Now I'm going to read the statements, and we're looking for the ones that are true. So I'm going to label each one as true or false. All ages pay the same price. Well, I've already looked at this graph, and we decided that as the ages here, they're changing, so is the price. So from 0 to 20, they pay a certain price. From 20 to 50, they're charging them a different price. And then from 50 above, they're charging them another price. Okay, so no, they don't all pay the same price. That's a false statement. So, false. Age depends on the cost of the ticket. Well, it is talking about age and cost. So we'll look at that one a little bit more in just a minute. Let's go ahead and read the next one. The older you are, the more you pay. Well, that doesn't really make sense because we're saying people between 0 to 20 pay $8 and people 50 to and on only pay $3. So this is backwards. So we're going to put that as false as well. And the last one says cost of a ticket depends on your age. And we have cost and age again, so we're going to look at that one compared to option number 2. So a lot of people get confused. Which way does it go? Which one depends on the other one? Well, we talked about in our previous lessons that y always depends on x. So y depends on x. This is our y value. This is our x value. So y always depends on x. So the cost depends on age. So now I need to find the answer choice that shows me cost depending on age. So age depends on cost? No, that's false. Cost depends on age. Yes, true. Number 9, given the table, what is the independent variable? All they're asking for is the independent variable. So I will list the x and y variables in my table. X always goes first. Y is always on the bottom. We said that y depends on x. So that means the distance from the entrance is the dependent variable, and the time in line would be the independent variable. The y always is dependent. It always depends on the x. So our independent variable for what they're asking for is time in line. Number 10. The height of a rocket is a function of the time the rocket has been in the air. Its path can be modeled with the function h of t equals negative 16t squared plus 20t plus 6. Which of the following represents the dependent variable in the situation? Okay, there is a lot going on in this problem, but the specific question asks, which one represents the dependent variable? Dependent variable would be our y-axis, or the thing that's depending on the other. In this problem, we're saying that height is a function of time. If I see is a function of, I know that's the same thing as depends on. Okay? So, the height of a rocket depends on the time. The question asks, what is the dependent variable? The dependent variable in this problem is the height. So B, height. Number 11, Henry is an AC technician and gets paid a fixed salary plus 5% of his total product sales. Given the situation, his total pay is dependent on which of the following? So which one depends on the other? Okay, so he's going to get paid a salary no matter what, but the rest of his earnings come from his commission, so he gets 5% of his total product sales. So his earnings really depend on how many sales that he makes. So the question says, given this situation, his total pay depends on what? On which of the following? So the pay depends on what his product sales are. So does it matter about how many units the AC company has in its inventory? No. It does not work for B either. The number of customers he visits, that doesn't even matter unless he sells them products. Letter C, the number of hours he worked. In the problem, it talks nothing about him working a certain amount of hours to make money. So that's out. And D is obviously the right choice because it says it's the amount of his total product sales. So depending on what he sells, determines how much money he will make. Number 12, which of the following relations is a function? I have 4 different representations here. I have a graph, a mapping, a table, and a set of ordered pairs. In each of these, I determine if it's a function by looking at the x values. In the graph, I would do a vertical line test. So I would draw a vertical line through my graph. And I would look to see if, for any x value, if I have 2 different outputs. In this problem, when x was 1, it crossed through when y was 2, and y was negative 2, or about there. So this would not pass the vertical line test because it goes through my picture at 2 different points. So the x value, right, I'm having the x value of 1 with 2 different outputs. So that's what makes it not a function. in the second option, so we'll put not function here. In the second one, the Roman numeral 2, we're looking at a mapping. We are only going to look at the x values. Okay, so the x values determine if it's a function or not. If I'm looking at when x is 2, it has one output of -1. When the x value is 4, it has one output also. It happens to be -1 as well. That's fine, as long as these x values aren't the same. Then I go to 6, and how many outputs does it have? It has 2 of them. It has one line pointing to 3, and the other one pointing to 5. I cannot have 2 lines coming out of one of the x values. That makes that not a function as well. Okay, option number 3, or Roman numeral 3, we're looking at a table. We have inputs and outputs, so we have x's and y's. We're only worried about these here. We need to make sure that for each input, it only has one output. So 3, I don't see any other positive 3's here, so that one's good. I don't see any other 2's, so that one's fine. I don't see any other -3's, that's okay. And then I don't see any other -5's, so that's okay. So this one is a function, so I'm going to label it F for function. And then we'll look at the ordered pairs. We're only, once again, looking at the x values, so we're looking at the first number in each ordered pair. And I have the numbers -3, 0, 4, and 8. They are all different. I don't see anything duplicated for the x values, so it is also a function. The question says, which of the following relations is a function? Or which of the following are functions, I guess it should say. So the two that are functions are option 3 and option 4. So we come down here and we look for 3 and 4 right here. So C is our answer. Number 13, which scenario best represents the graph? First thing I want to do is look at the graph. There's no title, there's no labels, there's no numbers. So I'm really just interpreting the graph itself, like the shape of the graph. I see that it's a straight line and it's going down, it's decreasing. So I'm going to look at the different scenarios and I'm going to decide which one shows just a constant decrease from for some set of values. So Bob was walking to the bus station and decided to stop at the library for 10 minutes, and then he continued on to the bus stop. So if we're looking at what our axes would be, we're talking about time, and we're talking about distance from the bus or to the bus station. So this would be distance, this would be time. So if he's walking to the bus station, it says he decides to stop at the library for 10 minutes. So he's no longer getting closer to the bus stop. He would actually stop for 10 minutes and then he would continue on to the bus station. So this shows a continuous rate, or he's going at the same pace, and that did not happen. He stopped for 10 and then he continued on. So A is not a good choice. Letter B. The speed of a peregrine falcon as it races down from the sky to snatch up a rodent from the dirt. Okay, no matter what I pick for the labels, we know that the speed of the falcon is going to change as it approaches the ground, right? If it did not approach the ground slowing down, then it would just smash straight into the ground. So at some point, we're looking at it curving here. So B would not be a good choice. C. The gallons of gas left in the fuel tank as the car is driven at a constant rate. We have gallons of gas and time, right? So over time, right? So if I started and I'm not driving anywhere, that's 0 time. And as time increases, what we're saying is that the gallons would decrease. So the number of gallons would go down. And that looks pretty good to me. So I'm going to put a question mark there. And for D, the temperature of water as it goes from room temperature to boiling. So again, we're going to have time here. So as time increases, we're saying that the water is going from room temperature to boiling. So that means that the temperature of the water would be increasing. So over time, we should see the temperature increasing. So this graph would be backwards. So D is also out. So the best option would have been C. 14. Which graph best represents the given scenario? I stayed at the library for an hour and then I walked home. The dependent variable is the distance from home. So our y-axis, the dependent variable, is going to be labeled distance from home. So I'm going to put DIS for each of these. Okay. The other variable that we're talking about is time. Okay, it says, I stayed at the library for an hour. So if I'm staying somewhere for an hour, is my distance changing? No. So here I see that immediately he's walking home. Okay, so the distance from home is going down as he walks home, right? He's getting closer. So if we were, a mile away and this is 0, right, we're getting closer to home, so the distance is decreasing. Here, if this is home and this is a mile away, I'm showing that I am walking away from home. In B, we see that the distance from home is not changing at all. If this is whatever we're saying, if it's a mile, right, I'm still in that same place over here at that amount of time. So both of these look good so far for staying at the library for an hour. Then it says, then I walked home. So the distance away from home as you walk home, it would be decreasing. So this one shows getting closer to home because the distance away from home would be decreasing. So B would be, I was walking somewhere else that was away from the house. So B is out. So A was out, C was out, B is out. D is our only good option here. 15, compare the graphs. Which statements are true? So I'm looking for true statements. We have lemonade stand A and lemonade stand B. This should have actually been eliminated, so we don't need that. We're going to read each of the statements and how they relate to each of the graphs and see how they relate to each of the graphs. So statement 1 says stand A is making the same amount of money every hour it is open. If we're looking at time, we're talking about hours, and we have money here on our y-axis. So stand A, it's making the same amount of money every hour it is open. Right here, I don't see an increase in money. The money level is staying the same. Then after some amount of time, then it starts making the same amount of money each hour. If it said stand B, then that would have been a true statement because the money's steadily increasing. So number 1 is false. Roman numeral 2, stand B made no money for the first hour and then had a steady profit. If I look at stand B, I'm showing that I'm making profit steadily the whole time. There is no amount of time where I'm making no money like I do in A. So if this one said stand A made no money for the first hour and then had a steady profit, that would be true. But we're looking at stand B. So this one is also false. Roman numeral 3, stand B had no money to start with and was unable to give out correct change. So if the amount of money here was 0, they had no money. Would they be able to give out correct change if they had no money to start with? The answer would be no. So that is a true statement. And option 4 says stand A had money to start with, but had no customers for a while. So if I look here, he is starting with money, right? That would be 0, so there is some money there. But they're not making any money, so they must not have any customers. And just for a little while, because after a certain amount of time, we can see that the money starts to increase. So option 4 is also a good answer choice. So 3 and 4 would be the answers here.